Making Fritzing parts from other sources, like photos and PDFs. Generally, this is only used in the breadboard view and for one-off parts. If it's going to be a high usage part that a lot of people will want, you'll tend to draw it to be more accurate. Here is a GM map sensor that I made from a photo, mainly because nearly no one will want this except me. The first thing we need is an image of the part we want to make. Generally, you need a photo from directly above with a white background and no logo if possible. With a part like this, a TPS sensor that doesn't get attached to a breadboard, it's not that critical. This looks good, but it has a watermark on it. Another watermark. This one looks good. Save that. If you can't find a photo and you have the part, you can actually take your own photo following the rules. Directly above, good lighting, white background. Now we have to fix up the photo for Fritzing, and that might even include using a photo editor beforehand to fix it up. Things like changing to a white background, cutting it out, and stuff like that. Now we open Inkscape, and we have to import it. File, import. We need our file. There are options here, but I just usually leave them as is, but you can experiment. Okay, we have that there. Now if we look at the XML editor, you'll see now the image has been inserted in here, but this is still the raster image. Now we have to make it into a vector, and you do that by going path, trace to bitmap. Now whatever these settings are at, when you press update is what it will display. Now we don't want that. We need colors. We'll take the smoothing off. Might have been better with the smoothing on. And number of scans, we might change that to 30. As you see, there's more detail now. You can also select remove background, but when I had to play with it, it didn't work that well, but it's up to you. And in fact, we'll be trimming it again anyway. If we're happy with that, we'll press OK. It takes a while depending on the number of scans. Now it's here. Now we go back to our original image we imported. We have to delete that. And now all we've got is the vector interpretation. If you actually look at the drawing, you can see shadow here. These are the things you might delete with a photo editor beforehand. There's a fault in Inkscape. When you press OK to trace to a bitmap, you can't undo that. If you're not happy with it, you have to close the page down again, open it up again and import it back in and start from the beginning. Okay, we don't need this anymore. Now we have to trim the drawing. So we'll have rectangle select, and we'll put a rectangle around it as close as possible. We'll grab this one, move it in a bit. Now this is the tricky bit. We'll select the original SVG, and then we'll hold down the Shift key and we have to select the rectangle we just made. And then we go to Object, Clip, Set. And that just cut it out. While we still have it selected, we now have to scale this down to the correct size that it actually is. So we'll go scale. We'll use millimeters because we have the actual item and we can measure it. First thing we want, scale proportionally, and the width is going to be 60 millimeters, and it comes out according to this 61 millimeters. We can check that too. Now we apply, and that's the actual size. While it's selected, we'll now make the page size the same as the object size. You just go, while it's still selected, edit, resize page to selection. We have that there. Click on there and go plus a few times. We have our object. Now we'll have to make our connector pins. First we need a grid to locate them. So we'll go File, Document Properties, and we'll go to Grid. We'll go New. That's a grid to these specifications. But we want now one from the origin, which will be here, right in the center, with this 60 wide, so we want one in 30 millimeters. So the X origin will be, this is set on millimeters, 30. Now we want spacing either side of the center line here. So we'll pick 5.02 mil, which is double 2.45 or 100 there. Next we have to do the Y origin, which will be about here. And if you look at the grid here, it'll tell you roughly where it wants to be. Y is about 1 millimeter, so the origin will be 1 millimeter. We might make that a bit higher so it's on the actual part. We'll change that to 2 millimeters. The reason we want this grid here is because we're going to snap the pins on the intersection points. And the reason why I'm using multiples of 100 thou is so we can snap into other parts. Not that this will be possible in real life, but just in case. To add our connector pins, we now have to do some editing in the XML editor. We'll change this name to Breadboard. Click on the ID. We change it to Breadboard. Set that. Now that's all our scans in one group. Now we have to make our contact pins here, which will be a 1 millimeter square in gold. So we pick rectangle. Just go from here to here. We'll now select gold. We have to change the stroke to gold, so we'll hold the shift down, press the same one. This has a bit of a radius corner from last time, so I'll set this while it's on rectangle select. We'll change it to 0. Take the radiuses out. Now we'll go to select and we'll lock them together. We'll change this in the millimeters to 1 millimeter. Now we'll duplicate that another 2 times. We can go edit, duplicate, or we can even just select one of these and duplicate with this button. We'll grab it and we'll snap it to this. We see it's not quite snapping to the intersection, so put it there. We'll have to pick snap centers of objects. We'll turn off snap cusp nodes. Grab it. Now it's snapping to the center. We select the other connector. We grab it. Snaps there. Select the last connector. We have that there. Now we have to change their names. We have that selected here. This will be connector 0 pin set. And now we'll do that for the others. Just copy it. Just change to pin 1, set, to set. Now it's important, if you're putting connectors on top of an image, it has to be at the highest level, so it always has to be below the actual breadboard SVG. So when you select it in Fritzing, you'll be selecting the top object, which will be the connectors, not the actual body of the part. Well, that does it for that part. Now we just have to save it. We'll go File, Save As. It needs to be a plain SVG, and we'll call it TPS, and save that. Just on a side note, the number of scans we did in the trace bitmap could slow down Fritzing, as you can see all these paths here. So you could delete some of these, but the more you delete, the more quality you lose. So always select the minimum amount of scans in a trace bitmap. That'll do the job. So now we'll go to Fritzing. Generally we'll close down all other Fritzing sketches because it can crash when you're editing a part, but we'll risk it with this one. Alright, first thing we need to do is find a part that's similar, that we can just add the SVGs to. Since there's nothing similar to a TPS sensor, we'll just pick a 3-pin header because it's got 3 pins. Right, now we'll right click edit. Now we'll load our TPS. Now we assign our pins. Let's say select graphic. It's already selected here, but see how it lights up? Just keep your mouse pointer over the pin you want until it's highlighted, and then click on it. Just muck around. So you can see it's a bit sluggy. We'll change pin 1 to over here. Just hover and wait. If you ever have a problem where you can't assign the pins, just close all Fritzing down again and open it up again, and it might clear the problem. Okay, we'll get these correct again. Pin 3. And then we'll save that as a new part. TPS. And now we come to my bin. And we have our breadboard. We'll just check if it works. Yep. Seems fine. Now you just have to go back in and re-edit the part and add the schematic view, the PCB view, the meta view and the icon, which I won't cover because it's in the previous videos. On a side note, this particular sensor doesn't fit a PCB board, so it won't have a PCB view. As a matter of interest, the map sensors that I made here do have PCBs, and I made a couple for different situations. Like this one here can mount a PCB and you plug jumper wires into the side of it. This one has the pins bent and can actually mount onto a PCB. And the schematics were just simple square drawings that are probably just modified linear regulator schematics. That covers one-off parts, but what about difficult stuff, like PCB modules? Here we found a photo that looks good enough, but what problems does it have? If you actually look at it, it's slightly tapered. So if it has to fit into the breadboard in breadboard view in Fritzing, there's only so much tolerance where the connector pins are located that it'll actually fit into there. This one in this case doesn't fit in because it connects to an Uno, but it's something like this. You wouldn't use a photo, you'd actually draw it because it has to plug into the breadboard and it has to be accurate. Going back to the other photo, the other problem we see, you can see these pins here are pretty vertical, directly on top. These ones are angled, you can see depth, and if you look here, even more angles. So it's never going to be perfect. The other problem is it's got a bit of shade here, which will be a bit annoying, but you'll have to live with it. And the other problem is the Inkscape conversion. Let's just save this and go to Inkscape. We'll go to the import again. Now we'll trace to a bitmap, path, trace bitmap, again colors. You can do the live update, but it's slow to update if you have a lot of scans. It looks a bit rough, take smoothing out, update, bit better, more scans. I'll just remove the background on this one to show you the error it has. Okay, and we'll go OK. It'll take a while because of all the scans. Alright, the remove background trimmed it here, here and here, but left this on the bottom. And if you look at these black things, there's like red bleed over, and nothing's really that good. Now, if we rectangle select from here to here, you can see it's a little bit out, it's tapered. And that's the problem with photos. And I've just noticed this spot down here. This is what caused the removed background not to work. Let's now look at this PNG. Looks pretty good. It's a PNG. Now we'll trace to bitmap. Path, trace to bitmap. Colors, update. We'll get it a bit bigger. Update. You can see the shadows in the header pins and now cause this blocky blurring, so we need more scans. Try 50, try 60, better. Might take the smoothing off, better. So we're happy with that, we'll go OK. And the result is still not that great. You might need like 120 scans. You may say this is a lot better than the other photo, but you've got to remember the original was a PNG drawing, probably even a vector drawing, so it started off better. Basically it's up to you if you want to use this method, but it's not recommended. You're better off just drawing it. And if you had to draw that board, you'd just be grabbing the SVGs of other parts and just cutting out sections of it and pasting it onto that. so you wouldn't be drawing much anyway. Now we're going to cover something bizarre. These were all made from imported PDFs. There's different quality of PDFs. This might have been drawn as a vector or a CAD or something, but it comes out very accurate in Inkscape. This was just a raster one. You can see how inaccurate it is. These are again accurate PDFs. So you go to your PDF, you save it. Open Inkscape. Now we'll import the PDF. I'll just leave this as OK. This takes a long time because there's a massive number of nodes in these drawings. Straight away you can see the lines, how sharp they are. This is no raster drawing, and you don't even have to trace it to a bitmap. In my drawing I use this view as the breadboard view with all the other lines deleted. Now there are two ways to get this drawing. You either ungroup it down to base level, select it in a rectangle and paste it to another one, or you individually node select each line one by one until you've got the whole thing, and then copy that to a new Inkscape drawing. The first ungroup method is you go Edit, select all, and then you go Object, Ungroup, and then you keep doing that until you get right down to the base level where it says no more groups to ungroup. Or the automatic way to get it fully ungrouped down to base level is go Extensions, Arrange, Deep Ungroup, and that'll break it down to every single individual node. The problem with this method, this could take over an hour because of all the thousands and thousands of nodes, maybe 20,000, 50,000. Then you just arrow select and then put a rectangle around it. Notice how the rectangle will disappear because it hasn't been ungrouped yet. And then when you've selected all your ungrouped nodes, just copy and paste it to another Inkscape drawing. The other method, the node method, is very finicky. You have to zoom this to massive size. We'll just get rid of that. Here we have our drawing. We node select. We come near the line we want, it'll turn red, click on it, it's selected. Hold the Shift key down, pick the next line. And just pick the lines that you want. If you pick the wrong line, just click on it again and it'll be deselected. Occasionally, you'd select the arrow key, and these will be selected, and then you move it, and then you know what lines you've got. Then just go Control Z or undo and it'll put it back. Select node again, hold the Shift key down and select more lines. This may seem very tedious, but when you do the ungroup and copy a section out, you still have to do this to delete all these lines that you don't want in that as well. So this method could actually be a touch quicker. Once you've got everything you want, copy it into a new SVG, just scale it, put a coloured box around it and add all your connector pins like in the other example. This raster based PDF is done the same way with the trace to bitmap, and that covers how to get a PDF drawing into Inkscape. Then you add the usual schematics. I modified a 40-pin IDE header, and the PCBs again have to be very accurately drawn because it's critical for production. On a side note, my first connector was the same PDF, the PCB view, where these were all just hand drawn, because once you know how to draw, it's quicker to draw it than using the PDF method when you're skilled at vector drawing.